Hello students, this is Dhanakumar. Today I am going to discuss about matrices and determinants. Matrices and determinants is a very important topic in 12th standard, right? From this topic also we can expect one question in JEE point of view, right? And before discussing about the problems in matrices and determinants, what are that models are very important for any competitive exam point of view, right? So first one is, let us coming to matrices. In matrices, what are that models important? In matrices, what are that models important? Inverse of a matrix, first important problem. And next, problems based on some special types of functions and problems based on special types of functions like symmetric, skew symmetric, orthogonal, identity, involutory, etc. Okay, and let us coming to determinants. In determinants, problems based on general determinants, something they will give you one determinant is equal to dash. So for solving such type of questions, so many methods are there, right? And next, recently they asked one question also, the maximum value of the determinant, maximum and minimum values. And next, one more important method is solving system of linear equations, that is consistent, inconsistent, for homogeneous, non-homogeneous problems are there, right? So these are the very important models in matrices and determinants. Okay. Now let us coming to problems one by one. First question, given conditions, you observe that one first here. If AB is equal to A and BA is equal to B, then show that A square is equal to A and B square is equal to B. Question understood? Here two conditions are given. AB is equal to A and BA is equal to B. These are the two given equations. At the last to prove A square is equal to A and second one B square is equal to B. Right? I think A square is equal to A, B square is equal to B. Both are same procedure only. We can prove this one both in same approach only. Right? Before solving this question, two important points. In general, in matrices, matrix multiplication is not committed to. Is it correct or not? Matrix multiplication is need not be committed to. In some special cases, it is committed to. In general, matrix multiplication is need not be committed. But matrix multiplication is associative. Matrix multiplication is associative. What is that associative property? Let us take some three matrices of that. See, I am taking three matrices A, B, C, whose multiplication possible. Matrix multiplication possible. Such type of matrices only I am selecting. Okay. Right. Associative property is A, B of C is equal to A of BC. A, B of C is equal to A of BC. Here nothing. Here A, B, C, A, B, C. Here first two elements bracket. Last two elements bracket is there. Okay, you have to follow like this. Okay, now coming to this question here. Here condition is what? AB is equal to A and BA is equal to B. These are the given two conditions, right? So let us coming to that given condition. AB is equal to A. AB is equal to A. Now next, multiplying both sides with A, post multiplication I am taking, that is AB of A is equal to A into A square. Okay. Now you observe this one. It is in the form of what? A B of C using associative property. A B of C is equal to what? A of BC. So that implies A of BA is equal to what? A square. So that implies A into BA. BA is what? B. That is that second condition. So AB is equal to A square. But AB is what? A. So A is equal to A square. A is equal to A square. Now you observe this one. Understood or not? Right. Hence proved this first condition. Now let us coming to second condition. B square is equal to B. B square is equal to B. Right. Now here same procedure for proving this A square is equal to A. First I took AB is equal to A condition. For proving this B square is equal to B, you take this second condition. So that is BA is equal to B. BA is equal to B. Right. Then BA is equal to B. At the last to prove B square is equal to B. Right. Again same post multiplication. Here I am multiplying both sides with B. Then only B into B square. Understood? Right. So BA of B is equal to B into B square. Again using matrix multiplication associative property, you see AB of C is equal to A of BC. So that is first element as it is, last to put bracket, is equal to what? B square. But AB is equal to what? Using first condition A. So BA is equal to B square. So implies, but what about BA? B. So B is equal to B square. Hence proved second condition also. Understood? So A square is equal to A and B square is equal to B. Observe that one procedure same. Clear? Right. Let us coming to next one more question. If an idempotent matrix is also skew-symmetric matrix, then it must be, your condition you observe that one, if an idempotent matrix is also skew-symmetric. Okay. Let us see. I am taking one square matrix A. Okay. Here I am writing. I am taking one square matrix A. A is one square matrix of order. I am assuming some n by n. Here idempotent matrix. What is the definition of idempotent matrix? If A is any square matrix of order n, then A square is equal to A. A square is equal to A. Then A is called idempotent matrix. A is called idempotent matrix. And what is skew-symmetric? Skew-symmetric and symmetric, two definitions are there. Even board exam point of view also, symmetric and skew-symmetric are both are important concepts. What is symmetric? What is skew-symmetric? Right. If A transpose is equal to plus A transpose is equal to plus A, then A is said to be symmetric matrix. A is said to be symmetric matrix. If A transpose is equal to minus A transpose is equal to minus A, then A is said to be skew symmetric matrix. Now understood? Here two conditions are given, idempotent and skew symmetric. If A square is equal to A, then A is called idempotent matrix. If A transpose is equal to minus A, then A is said to be skew symmetric. Okay. So, if a square matrix A satisfies these two conditions, these are the given two conditions, then it must be dash. First one involutory matrix, second identity matrix, third orthogonal matrix, fourth one null matrix. Okay. Null matrix means what? Null, 0. All the elements in the given matrix are zeros, then the matrix is said to be null matrix. Okay. A transpose into A is equal to I, then it is said to be orthogonal. Identity means that we know that one identity matrix. Suppose identity of order 2, 1, 0, 0, 1. Okay, that is called 2 by 2 identity. And involutory, A square is equal to I, then A is said to be involutory. Now here out of these four, which one is correct, that you have to check it. Simple thing. Okay, let us say here first condition I am taking. What is that first condition here? A square is equal to A. Now here second condition, A transpose is there now, right? So by applying transpose on both sides, then it becomes A square whole transpose is equal to A transpose. A square whole transpose is equal to A transpose. Now coming to this one, one property is there, A square whole transpose. So this can be written as A transpose whole square. A transpose whole square, interchangeable. So that is equal to, but A transpose is what given condition? Minus A. Understood? But see here, A transpose is equal to what? Minus A. So minus A whole square is equal to what? Minus A. But minus A whole square is equal to what? A square. Is it correct or not? Right. A square is equal to minus A. But A square is what? A only. A is equal to minus A. Minus A, shift this side, plus A. A plus A, 2A. 2A is equal to what? Null matrix. 2A is equal to null matrix. A also what? Null matrix. Understood procedure? Here two conditions are given. What are the two conditions? Idempotent matrix and skew symmetric matrix. So what I did, first here I am taking first equation. Here second condition, A transpose is there. That is why I am taking a apply transpose on both sides. So A square whole transpose can be written as A transpose whole square. Both answers will be same. But A transpose is minus A. Similarly, A transpose minus A. Minus A whole square will be what? A square. But A square is what? A. And then simplification. So here we got A is what? Null matrix. So fourth option correct. Understood? Right. Now let us coming to next one more question. Now here multiplication of matrices concept. Here you observe this one. If the product of n matrices, product of how many matrices? N matrices. Product of these n matrices is equal to this matrix. Then find n. Here n value possibilities 26 or 27 or 377 or 378. These are the 4 options. Okay. Out of these 4, which one is correct? Right. Now simplification, just you see here. Here n value, first of all, we don't know. Actually calculated part only n. So how to do? So you have to multiply. Can you multiply all the matrices? It is not possible because we don't know n. So what to do? Here you do 2 or 3 matrices. Better you do 3 matrices. First 3 matrices multiplication answer you find out. Using that answer, we can write it easily, product of n matrices answer. Understood my point? Okay, let us see you can understood. First, I am taking first 2 matrices. That is 1, 1, 0, 1. First matrix into. Second matrix is what? 1, 2, 0, 1. First of all, my question is, here matrix multiplication possible or not? Generally, matrix multiplication possible or not? Let us see. Order of first matrix is what? 2 by 2. 2 rows, 2 columns. Second matrix, 2 by 2. Right. Now here, what is that rule behind this multiplication? First number always indicates number of rows. Second element represents number of columns. So number of rows for first matrix 2, number of columns for first matrix also 2. Right. What is that condition? If the number of columns in the first matrix is equal to number of rows in the second matrix, number of columns in the first matrix is equal to number of rows in the second matrix, then we can say that matrix multiplication possible. Matrix multiplication possible. And missing elements you see here 2, here 2. So missing elements 2 by 2. So resultant matrix means after multiplying these 2, we can get one answer. Na? That answer matrix order is 2 by 2 only. That is the meaning. That is the conditions behind this multiplication. Understood? Okay, fine. Here multiplication possible. Answer matrix order also 2 by 2. Finish. But how to multiply? That is our question. How to multiply these 2 matrices? First matrix, it is just like 7 shape. Okay. First matrix you take like this, multiplication. Second matrix you take like this, 7 shape. Now you do that multiplication here. What is that answer you see? First element always multiply with the first element only. 1 into 1, 1. Plus 1 second element multiply with the second element. Second element means in second matrix you take column wise like this order. First matrix row wise, second matrix column wise. So 1 into 1. Always multiply first element with first element, second element with the second element like this order. So 1 into 0, 0. Fine. Next 1 into 2. 1 into 2 is what? 2. 1 into 1, 1. Next 0 into 1, 0. 1 into 0, 0. Next 0 into 2, 0 plus 1 into 1, 1. So that is equal to what? Answer 1, 2 plus 1, 3, 0, 3. See here simplification. Sorry, 0 into 2, 0. 1 into 1, 1. So answer is 1301. 1301. Just you observe this one. First, okay, suppose if you are taking last matrix. Here 1 0 1 1 0 1, but here number different. Okay, let us see. Fine. First two matrix multiplication answer we got this one. This into third matrix. What will happen? You see. Here this matrix is what? 1 3 0 1. Next third matrix 1 3 0 1. So that implies simplification. 1 into 1 1, 3 into 0 0, 1 into 3 3, 3 into 1 3. Next 0 into 1 0, 1 into 0 0, 0 into 3 0, 1 into 1 1. So that is equal to 1, 3 plus 3 is 6, 0, 1. Here also we got same format only. Enough. 3 matrices I multiplied here. Enough. Now condition, and you observe that one small relation is there. One small relation is there among the first two multiplication answer in this answer. Just you see 1 0 1, 1 0 1, same. And 3 can be written as, for our convenience, 1 plus 2. Any problem? Right. 6 can be written as 1 plus 2 plus 3. Means, now you observe this one. See, if you are multiplying first 3 matrices, finally we got answer is 1 0 1. And here, especially in second element, you see sum of these 3, 1 2 3, sum of these 3 numbers is equal to what? 6. Same thing we got. If you are doing multiplication first 2, 1 plus 2 3, same answer, right? So if you are multiplying all these n matrices, we can get this format only. 1 0 1, same only, same order. And here, what about this one? Here, first 2 if you are multiplying, we got this plus this. First 3 means sum of these 3. All n matrices means sum of these n elements. Correct or not? Right. So, answer will be 1 plus 2 plus 3 plus so on n. Right. Now, but actual condition is what? 1 0 1. Here value 378. 378. Now let us coming to simplification. Two matrices are equal only when corresponding elements is same and order of two matrices also same. Anyhow, order of two matrices same. Then you have to equate that corresponding elements. Second element is what? This one. 1 plus 2 plus 3 plus so on n. Sum of first n natural numbers. Sum of first n natural numbers formula is what? N into n plus 1 by 2 is equal to 378. Okay. Simplification. Cross multiplication. N into n plus 1 is equal to 2 into 378. 2 into 378. Answer is 2 8s are 16. 2 7s are 14 plus 1 15. 2 3s are 6 plus 1 7. So finally we got answer 756. Here we got answer 756. Fine. Actually we want n value. Correct or not? What is that procedure? Expand this one. We can get quadratic equation, roots find out. Otherwise, you go for better options verification. What are that options here? First of all, if you are taking fourth option answer is what? 378. If you are taking n is equal to 378, simple logic, n plus 1 will be what? 379. If you are multiplying these two, this is 3-digit number, this one also 3-digit number. 3-digit number into 3-digit number, we can get 3-digit number? No, more than that. So obviously, fourth option wrong, third option also same format wrong. In these two, which one is correct? Right? Suppose if you are taking first option, what will happen? N is equal to 26. Fine. N plus 1 will be what? 27. Product. No need to multiply completely also. 7 6 are how much? 42. Units place digit 2. But here 6. Both are different. So this option also wrong. So correct answer is 27. Understood? Right. Now let us coming to next one more question. Let A, B, C be non-zero real numbers if the system of equations is consistent. What is the meaning of that word consistent? Consistent means it has a solution. It has a solution. Now, in matrices and determinants, consistent, two types of solutions. What are those two? Unique solution or infinitely many solutions. So, whatever it may be, given system has unique solution or infinitely many solutions, whatever it may be in these two, system is said to be consistent. Clear? Right. And B is equal to 4A plus C by 4, one condition. Then the absolute value of sum of the roots of the equation is equal to dash. Absolute value of sum of the roots of this equation. Fine. Okay. First of all, suppose alpha comma beta are the roots. Then sum of the roots formula is what? First I am writing formula. Sum of the roots. Sum of the roots formula is what? Minus b by a. Sum of the roots formula minus b by a. Right. If you know the value of a, b values, directly we can substitute. Problem is over. Understood? So here we want a value and b value. How to find a, b? Two conditions. What are the two conditions? One is this. Second one is consistent part. Correct or not? Okay. Let us see. I am rewriting that given equations. You observe this one like this. One order I am writing. Plus 2x, shift this side. It becomes minus. So minus 2x plus y plus z is equal to what? A. Next, x plus 2y, shift this side, minus 2y, x minus 2y plus z is equal to b. And next, x plus y minus 2z is equal to what? C. Okay. Here A, B, C are what? Non-zero real numbers. So non-zero real numbers means given system is said to be homogeneous or non-homogeneous? Right, non-homogeneous. Non-homogeneous system of equations is given. Okay, right. Let us see. First I am calculating delta. Delta means determinant of this coefficient matrix. Here one order I am writing. First equation x, y, z coefficients write down in first row. Second equation coefficients write down in second row. Third equation coefficients write down in third row. Understood? Okay. First equation coefficients minus 2, y coefficient to 1, Z coefficient 1. Second, 1 minus 2, 1. Third, 1, 1 minus 2. So that is equal to what? Determinant general procedure. Symbols plus, minus, plus. Okay. Minus 2 into, neglect this row and this column. Then remaining minus 2 into minus 2 plus 4. Minus 1 into 1, 1. Next, minus 1 into, neglect this row and column. 1 into minus 2, minus 2. 1 into 1, 1. Plus 1 into, neglect this row and column. 1 ones are 1. 1 here, simplification value is what? Minus into minus plus 2. So that is equal to what? 4 minus 1, 3. 3 2s are 6. So minus 6. Here, minus 2 minus 1, minus 3. Minus into minus plus 3. Here also plus 3. Minus 6 plus 6. Answer is what? 0. Okay, answer we got 0. Let us coming to Cramer's rule. Using Cramer's rule formula, small x is equal to what? Delta 1 by delta. Y means what? Delta 2 by delta. Z means what? Delta 3 by delta. Now here we got delta is 0. Right? Just simple logic. You can take any one formula, either x part or y part or z part. Let us say I am taking x part. Suppose if delta 1 value not equal to 0. Generally, delta 1 possibilities are what? Delta 1 answer may be equal to 0 or may be not equal to 0. Correct or not? Suppose delta 1 not equal to 0. For example, let us say 100. 100 by 0. 100 by 0 is what? 100 by 0 is 0? No. 100 by 0 is what? Infinity. Not defined. Right? So not defined. But here condition is what? Consistent. Consistent means it has a solution. Solution exists. So delta 1 not equal to 0 is not possible. Delta 1 must be 0. Delta 1 must be 0. Similarly, delta 2 also 0. Delta 3 also 0. Because given condition, system is said to be consistent. Understood? Right. Anyhow, I am taking delta 1. N of 1 part. How to find delta 1? Delta means I wrote like this. Delta 1. 1. Order you follow like this. X, Y, Z. 1, 2, 3. Or otherwise C1 column, first column, second column, third column, like that. Here 1 is there. 1 means C1 corresponding number, correct now? So replace first column elements. Replace first column elements by right hand side constants. Right hand side constants. So that is delta 1 is equal to A, B, C. A, B, C. Second column, third column as it is. 1, 1 minus 2, 1. 1, 1 minus 2, 1. And here 1 minus 2. 1 minus 2. Okay. 1, 1 minus 2, 1. 1 minus 2. So this delta 1 answer also what? 0. Right? Now simplification. Expand this data. Plus, minus, plus. A into neglect this row and column. Right? Remaining minus 2 into minus 2 plus 4 minus 1. Next, sign minus, number is 1 into, neglect this row and call b into minus 2 minus 2b, b into minus 2 minus 2b minus c plus 1 into, neglect this row and call 1 into b, b minus into minus plus 2c is equal to what? 0. Okay, let us say simplification. 4 minus 1, 3. 3 into a, 3a. Here minus into minus plus 2b plus c plus b plus 2c is equal to 0. So that implies one order I am writing 3a, 2b plus b, 3b, c plus 2c, 3c is equal to 0. Divide both sides with 3. A plus b plus c is equal to 0. One relation we got. Okay. Let us see next slide. Here we got a plus b plus c is equal to 0. Implies c value how much? Minus a minus b. One more condition is given. What is that one more condition you see? b is equal to 4a plus c by 4. Okay. Actually we want sum of the roots. Sum of the roots formula what we wrote? Minus b by a. We want AB values only. Correct or not? We don't want C. Means eliminate C. Eliminate C. Simple thing. See here. First of all, here simplification. LCM 4. 4 4s are 16. 16A plus C. Cross multiplication. 4B is equal to 16a plus c. Correct na? Now eliminate c. Put c value here. 4b is equal to 16a, c value minus a minus b. One order. Minus b shift this side. 4b plus b, 5b is equal to 16a minus a, 15a. Here 5 1s are, 5 3s are. Correct now? A shift this side. B by a is equal to what? 3. Therefore, sum of the roots is equal to formula minus b by a. So minus 3. But actually calculate what? Absolute value. Means take modulus. Modulus of minus 3 is what? Plus 3. So third option correct. Understood? Simple question only. But here in this question consistent along with quadratic equations concept also involved. Clear? Right. Let us coming to next one more question. See, matrices and integration concepts. Let A is equal to Aij be 3 by 3 diagonal matrix. Diagonal matrix means what? Let us say for example, just one example I am writing. Say for example 1 0 0 0 something 5 0 0 0 something 8. This is called what? Principal diagonal. Not all principal diagonal elements are zeros. Other than principal diagonal elements are zeros in the square matrix, then the matrix is said to be diagonal matrix. Right? Determinant of diagonal matrix is what? Determinant of diagonal matrix is product of principal diagonal elements. Product of principal diagonal elements. Okay. Right. See here, A is 3 by 3 diagonal matrix with A11 e power x, A22 e power x, A33 e power x. Then find integral 0 to 1 det A dx. That is our question. Simple question only. Let us say first of all A is equal to, if you are taking like this matrix, A11, here condition is what? Diagonal matrix. So 0 0 0, this is second row second column element, 0 0 0, this is third row third column element. Now what I told, determinant of diagonal matrix is equal to what? Product of principal diagonal elements, that is A11 into A22 into A33. So that is equal to what? A11 e power x, A22 e power x, A33 e power x. Now here we got det A answer. Now you find integral 0 to 1. Okay, let us say first integration I am calculating. Integral 0 to 1 det A dx. That is our question. Correct na? Right. Now integral 0 to 1. Right. Det A answer is what? E power x into e power x into e power x dx. Okay. Now how to find integration? That is our question. Simple thing. In general exponential problems are there. E power value not equal to x, one possibility. Assume that power is equal to some other letter t. Understood? Okay. Let us see here. This part I am assuming t. Put e power x is equal to what? T. Right? Now differentiate. I am assuming this power is equal to x. It is in the form of e power x. E power x derivative is e power x. So that is e power x into derivative of e power x. E power x derivative is e power x. Dx is equal to what? Dt. Right? Now you substitute integral. Okay. First I am finding integration. Later we will do that limits substitution. This part e power x into e power x is what? Dx is dt. And this is e power t. E power t dt. Integral e power t means what? E power t only. So that is equal to what? E power x. This is integration. But here limits 0 to 1 na? So substitute lower and upper limit. So answer will be what? X is equal to 1, substitute e power e minus e power 0 is what? 1. That is the answer for this question. Right. So that is first option correct. Clear? Let us coming to next one more question. Simple and logical question. First you see that statement. A be a square matrix of order 2. Square matrix of order 2 means 2 by 2 matrix. Fine. With Aij belongs to. So elements in the matrix belongs to this set. Fine. Find the number of matrices A with distinct elements. Distinct elements means different element, such that A into A inverse is equal to I, where I is the unit matrix of order 2. That is the question. Question understood or not? Question understood or not? Find the number of matrices A how many matrices A, how many matrices exist with different elements, and also condition is what? A into A inverse is equal to I. Satisfies this condition. So satisfies this condition, like that how many matrices are there? That is our question, right? So simple logic, blindly if you are taking some A is equal to like this 0, 1, 2, 3, then verification, next 1, 2, 3. If you are manually, if you are doing, I think it is very difficult. Then how to do this? Simple logic behind this one, you observe that one. A into A inverse is equal to I, means A inverse matrix exists or not? Right, exists. A inverse matrix exists. Then only product answer is I. If A inverse does not exist, how can we write like this? A into A inverse I. Is it correct or not? Right. Means here A inverse exists. Since A inverse exists. What is the formula for A inverse? Generally, A inverse formula is adjoint to A by det A. Adjoint A by det A. If det A not equal to 0, if det A not equal to 0, then inverse exists or not? Right, inverse exists. Now easy, I think, right? Det A not equal to 0. Let us say I am assuming A matrix is A, B, C, D. Here A, B, C, D, 4 elements are different. All these 4 are different, and these elements belongs to this set. Elements belongs to this set. Fine. So that implies that A formula is what here? AD minus BC. AD minus BC. So AD minus BC not equal to 0. That is our question. Okay. Let us say here one simple approach I am following. What is that approach? See, for example, in a classroom, same example in earlier session, in probability also I explained same example. You see, in a class 100 students are there, right? 70 members passed in one exam, then failure, total minus passed, correct or not? Right. Det not equal to 0, here we want total possibilities minus det is equal to 0. Total possibilities minus the number of possibilities for which det A is equal to 0. It gives det A not equal to 0. Is it correct or not? Right. So I am taking det A is equal to 0. I am taking det A is equal to 0. Right. See here. See that next slide. Now det A answer is what? AD minus BC is equal to 0. Implies AD is equal to what? BC. Here ABCD belongs to what? 0, 1, 2, 3, 4, 6. Okay. 0 possibilities 1, 2, 3, 4, 6 only. Total 3 plus 3, 6 possibilities are there. Fine. AD is equal to BC. What are that possibilities you see? Let us say suppose 1 into 6 if you are taking. If you are taking with 0 means answer 0, but here we want a different element. So with 0 means there is no possibility. You take 1. 1 into 6 I am taking, sir. 1 into 6 is 6. Next possibility 2 into 3. Any of these 4 elements different or not? Right. Here 0 if you are taking, it is not possible. Why? Suppose just you see 0 into 1 if you are taking. Answer 0. Next answer also we want 0. That possibility must and should be 0 into some other number. But here condition is what? all 4 elements are different, but here 2 zeros are there, means what? Same. So our condition satisfies? No. That is why I am not taking 0. Excluding 0 only possibilities are there. 1 into 6 is equal to 2 into 3. Next, is there any other possibility? Just can you observe that one? Any other possibility? Can you guess? Right, 2 into 6. 2 6 are how much? 12. 3 4s are 12. Satisfies. Apart from these two, is there any other possibility? Apart from these two with different denomination, is there any other possibility? No, that's all. Right, let us say here 1 into 6 is equal to 2 into 3. Like that, how many possibilities exist? Total 8 possibilities are there. Total 8 possibilities, 8 choices. Right? How sir you wrote 8? How it? Just you see here. For example, if you are taking like this, okay, here A 1 D A D na A D B C A D A1 D6 B2 C3. Here that is 0 or not? Right, 0. Suppose if you are taking like this 1 6, interchange these two, here 2, here 3, again possibility is there. Is it correct or not? Right. Next possibility, now you interchange 1 6, here 6, here 1, 2 3, next 6 1, here interchange 3 2. Is it correct now? Total how many possibilities? 4. Sir, here we got 4 possibilities, but you wrote 8. How? Again question mark. Correct now? Just reverse you write. That is AD is equal to 2 3, BC is equal to 1 6 you take. Understood? Then also that answer 0. Right? So that is AD 2 3 means here 2, here 3. Okay. Here 1, here 6. One possibility. Again that is 0, but with different elements you see, these two are not equal, right? Next 2 3, interchange these two, here 6, here 1. Next these two reverse rider, 3 2, 1 6. Next 3 2, here 6, here 1. Now how many possibilities? 8 possibilities. That is why I wrote starting only 8. Similarly, if you are taking this one, again how many possibilities? Same way we can write it. How many? 8. So total possibilities will be what? 8 plus 8. Total, yes, 16 possibilities are there. All these 16 possibilities, determinant answer is equal to 0. But here we want a determinant not equal to 0. Is it correct or not? Right. So what I told are the total possibilities minus determinant equal to 0. So total possibilities I am writing. Total number of possibilities. Okay. Here what are the elements? 0, 1, 2, 3, 4, 6. Total how many possibilities? 6 are there here. 6 elements are there. 2 by 2 matrix means we want 4 elements. Correct now? We want 4. All 4 elements are different. Right? So here simplification. For here we want 4 elements. So you have to select 4 elements from 6 elements. Select, selection. Apply which concept? Combination. Selection means combination. So total 6 possibilities. Out of 6 select 4. 6C4 into. Internally you have to arrange 4 places. 4 elements can be arranged in how many ways? 4 factorial ways. Now understood what I told? Just you see again I am explaining. Total here 6 elements are there. 2 by 2 matrix means we want only 4 elements, because here elements, all 4 elements are different. Clear? Okay, we want 4 only. So you have to choose 4 elements from this set. So select means what? Combination. That is why 6C4 I wrote. After that, internally arrange these 4 places. 4 places can be arranged in how many ways? 4 factorial ways. Okay, so that is equal to simplification. 6C4. 6C4 can be written as 6C NCR is equal to NCN minus R. Okay, is it correct or not? NCR is equal to NCN minus R. 6 minus 4, 2 into 4 factorial. Now you simplify. 6C2 can be written as 6 into 5 by 2 into 1 into 4 factorial. 4 factorial is 24. So here 2 3s are 3 5s are 15. 15 into 24. Simplify. 15 4s are 60. 15 2s are 30 plus 6. 36. So total here we got 360 possibilities are there. Using these 6 elements, how many 2 by 2 matrices are formed with different elements? 360 possibilities. According to our question, determinant not equal to 0. So what I told? Total possibilities minus determinant equal to 0. But determinant equal to 0, how much we got? 16. So 360 minus 16, that is equal to 60 minus 10, 50, 50 minus 6, 44. So total here we got 344. So you see, so here calculate what? Number of matrices. So total how many matrices are possible with distinct elements and also satisfies A into A inverse is equal to I. How many possibilities? 344 matrices are possible. Understood? Right. In next session, I will explain with some other topic. Thank you.